Now, in the Tetra standards, the encryption that's applied or is defined in the standards is air interface encryption. So in other words, the methodology used for encrypting the connection between the radio, the mobile, and the base station is defined in the standards, and that's Tetra air interface encryption. So in other words, from the base station into the core network, the SWIMI, then the speech would therefore be in the clear if you only applied Tetra air interface encryption. However, Tetra is capable of supporting end-to-end encryption within the Tetra SWIMI. Now, this could be a proprietary encryption algorithm, which is installed on each mobile and allows mobiles to communicate with each other with all of the data, the signaling and the voice, if you so require, all of those to be encrypted. They can be encrypted end-to-end, and you can apply a proprietary or your own encryption technology. Now, most of these encryption technologies need some sort of synchronization mechanism so they know where they are in the encryption routine. And the Tetra standards do specify how to support that synchronization technique methodology. So the synchronization is set in the standards. The actual encryption technique you use can, in effect, be up to you. And that's all well and good, of course, when it goes from one Tetra mobile out to another Tetra mobile. We could support Tetra end-to-end encryption, no problem. But when we go through the IWF, we will hit this security gateway on the 3GPP side that interfaces to the 3GPP system, So what we can do is we encrypt end-to-end all the way through the network or just over the air interface and strip that encryption off on the security gateway and then pass it over to 3GPP network security techniques this side. Now, this, of course, creates a bit of an issue from maybe a security perspective, which is, how do we handle security keys? How does this, well, basically that's the issue. How do we handle the security keys? Do we want to go through a de-encryption process here and then an encryption process there? We might have to. Or if we are going for end-to-end encryption, do we want to take this Tetra end-to-end encryption all the way through to the 3GPP mobile here? Now, that can be supported. That's not a massive problem. It's catered for. But to do that, the 3GPP mobile here must support the Tetra codec. There's no other choice because the voice was coded here on the Tetra mobile using the Tetra codec, passes through the entire system, or systems in this case, and is decoded here, where they must, of course, support the codec, otherwise they won't be able to understand the voice. So that's the key issue there. The 3GPP mobile must be able to support the AKELP codec, as Les mentioned. So the decision on what to encrypt and where to encrypt will, of course, be an operational decision made by, usually, of course, the mission-critical operator themselves. How much encryption? Do they want just the air interface encrypted, end-to-end encryption across Tetra, or end-to-end encryption across Tetra and through to LTE? And if they do want that latter one, they must support the AKELP Tetra vocoder on the mobile device on the 3GPP network. So that's the key issue there from the security perspective.